Greetings and welcome. In this video session we will discuss about cooling load estimation of HVAC system. Now in last some video sessions we have discussed about the different fundamentals, basics which are required in a heat load calculation, that is a psychrometry, different psychrometric properties, then the use of psychrometric chart, various psychrometric processes. Now here we will have one example where we can find the cooling load for the HVAC system. So this is a statement. In an air conditioning system, following are the details. The outdoor condition is given. The room condition is given. Ventilation, air circulated. And we have to find these three parameters: supply air flow rate, capacity of the cooling coil, and amount of water removed. So first of all, these are the given parameters and listed over here. The condition of outdoor air we can locate by point 1, and condition of indoor air we can locate by point 2 on the psychrometric chart. So here this combination of any two properties is required to locate a point, that we will see now, application of these 2 points. And if we join these 2 points, then we will find the process, that is a cooling process. So first property is dry bulb temperature is 35 degrees Celsius and relative humidity is 60%. So let us first of all locate this point 1 and point number 2, 25 degrees Celsius dBT and RH 50%. So this is a psychrometric chart. Here the first category, that is outdoor air condition by point number 1 with the help of 2 parameters: dry bulb temperature, which is given here 35 degrees Celsius, and relative humidity is a 60%. So this is a 60% curve. So we have to select this 60% curve. Then if we project from this 35 in upward direction, here we will find intersection point. Intersection of the 60% relative humidity curve and dry bulb temperature line of 35 degrees Celsius. 35 degrees Celsius. And this one is a 60% relative humidity, RH. So in this way you can locate point number 1. Second point, that is a indoor condition. This is what? Outdoor condition. This is outdoor condition, OD. So indoor condition will be located with the help of properties. Here 25 degrees Celsius dry bulb temperature is given. So this is a 25 degrees Celsius. So here this dBT 25 degrees Celsius, and relative humidity is a 50%. So this is a 50% line. This. So we have to take into consideration this line. So intersection of these 2 lines. Here you will find point number 2. This is what? 50% RH. So in this way we have located point number 1 and 2. This is what? Indoor condition, ID condition or room condition. It is called as room or ID condition. So if you join these 2 points, these 2 points, then this will be a process from 1 to 2. Now this process is what? In which the temperature is reduced and moisture content is reduced. Both are reduced. And this process is a cooling and dehumidification. So process 1, 2 here given. This is what? Combination of cooling and dehumidification. Psychrometric processes. Now here we have to obtain the values which are required for the calculation. So in the calculation we require enthalpy. So from point number 1, if you go in upward direction, here you will find the enthalpy for the point number 1. So this enthalpy is coming on this scale. So here this value H1 you get, that is 90 kilojoule per kg enthalpy at the entry. Similarly, if you project this point number 2 in upper way here on this scale, there you will find enthalpy H2. Now if you project these 2 points on the right side on the humidity scale, we will find here values of moisture content. So here point number 1 will give value here of this. This will be W1 and here will be W2. So it comes 0.010 kg per kg. And if you take this value, then it comes below 0.022, below that 2 divisions. Means we have to take value of 1 division is mentioned here, 0.0004. 2 division 0.0008, that we have to subtract from the 22. So it comes 0.0212 W1 kg per kg of dry air. Enthalpy here you take 50 kilojoule per kg and inlet enthalpy you take 90 kilojoule per kg. So we have got here now specific humidity values for inlet outlet and enthalpy values for inlet outlet. Now the value of specific volume we require to find at point number 1. So for that purpose you have to take intersection this point, and if you take this line is in between 0.9 and 0.92. So here it is closer to 0.9. So specific volume of this point number 1, that is a VS1. So that will be greater than 0.9. So you can take this as a 0.902 meter cube per kg. This is a specific volume. We require this specific volume in the calculation of mass flow rate. So let us now enlist all the values which are obtained here. So here these are the outdoor conditions mentioned, indoor conditions mentioned. Point 1 outdoor condition, indoor condition point 2. This is a psychrometric chart. Location of point number 1 with the help of values 35 and 60. Location of point number 2 with the help of values this DBT and this RH joining the line process. Then projecting point number 1 to all direction, right direction humidity, upper direction enthalpy. Similarly for point number 2. So now these values we will use for the calculation. Now at the point 1, amount of air supplied, this is a supplied air. this supplied air is a given ventilation air in a cmm, that we will see. Now for cmm means what? Meter cube per minute. So here we convert this value in meter cube per second. So for that purpose, V dot is equal to 100 divided by 60. So this volume flow rate we use for the calculation of the mass flow rate. So these are the values which we have obtained from the psychrometric chart: enthalpy values at inlet outlet, specific humidity values at inlet outlet. Enthalpy of air means heat content. Inlet outlet of coil, and these are the humidity values, moisture content. Before and after, we call this in this way: before and after coil. And this is a value given, that is a supply air given, and specific volume it is obtained from chart. Now we will use these values to calculate the load. Now the process which is taking place here, this is what between point number 1 and 2, and process is taking place from 1 to 2, and this process is what? Cooling and dehumidification. Means here will be two calculations: capacity of cooling coil, and second will be amount of dehumidification carried out. So first of all, we will see about the cooling load, capacity of cooling coil. So first calculation will be Q dot L, means cooling load. Cooling load Q dot L is equal to mass flow rate into enthalpy difference between inlet and outlet. So let us put the values. Now mass flow rate we have to obtain by using the formula, that is V upon Vs1. Vs1. V dot volume flow rate divided by specific volume. So putting the value of volume flow rate, so here by putting the values, volume flow rate in meter cube per second 1.67, specific volume we have obtained from the psychrometric chart in meter cube per kg, enthalpies before and after the process 1 and 2, 90 minus 50. Doing this calculation, we find this value in kilowatt. This kilowatt value we can convert by dividing it with 3.517 factor. We get the value in TR, means turn of refrigeration. So cooling capacity of the cooling coil or cooling load, by the calculation we obtain here in a TR and in kilowatt also. So second calculation is amount of water vapor removed from air, means it is a dehumidification process. During the dehumidification process, the process which is taking place in this fashion: 1, 2, here we find W1 and here we find humidity values from the psychrometric chart. So formula is what? Mass flow rate supplied at the 1, and during the process amount of moisture content reduced. So W1 minus W2. So these are the values from the psychrometric chart we put. If you do the calculation, we find this dehumidification in kg per second. Now this humidification can be mentioned in a different units. If we multiply this value with 60, we find this moisture removal in kg per minute, and if we multiply it with 3600, we find dehumidification in a kilogram per hour. This amount of water vapor removed in 1 hour. This. So as per the requirement, amount of vapor removed can be mentioned, either kg per second, kg per minute, or kg per hour. So in this way, we have methodology for the calculation purpose for this statement given. Supply air flow rate, that is a mass flow rate, m dot a, we have calculated. Capacity of cooling coil either in kilowatt or ton of refrigeration, and amount of water vapor removed in kilogram per second. So these three values we have determined under the title cooling load calculation with the help of psychrometric chart. So let us meet in the next video session of the HVAC. Thank you.